going to now do the fourth section of chapter 1 in geometry. This one is subsets of lines and planes. We've talked about points, lines, and planes. Now we are going to break them up. You can't break up a point because it's just a point. But when we get to lines and planes, we can divide them up into smaller sets. And what would those be? And how would we denote them? And what are they called? So that's what we're going to look at in this section. So a line is just a series of points. If you notice, I drew a line on the board. Notice that points B and C are on the same side of point A on line K, just to give you an idea. Remember that lines go on for infinity in both directions. Okay, so a half line is all the points on a line that are on one side of a point, but excluding that point. So in other words, if I made point A my dividing line of the line, then all the points on one side of A would be the half line, but you don't count A. So if I want to denote all the points on this side of A as this half line, then I would designate it this way. I start at A and I go in the direction of B. I could make that second point a C if I wanted, it doesn't matter. And then I'm going to show that I start at A and then I do that half line there. Notice I did an open circle above the A because since it's a half line, I'm not including A. So this leads to our line separation postulate. Every single point on a line divides the line into three disjoint sets. That point itself and the two half lines on either side of that point. So I could do at B as well. So B would be the point, then I could have BA as one half line and BC as the other half line. The point is called the origin of the half line. So just so you know, it's called the origin. Sounds similar to a coordinate plane, doesn't it? A ray is the union of that origin point and the half line. So if instead of showing this half line that starts at A and goes through B, if I want to make it a ray, then A would be included, and this would no longer be an open circle. But notice my arrow only goes in one direction, like that. A is the origin point. This does not start at B, it starts at A. It goes through the direction of B to infinity. That's called a ray. And you can think about it, you shoot a ray gun. It starts at one point and it goes forever in one direction. So I just wrote this on the board so that you could see that you can name rays different names as long as the origin point is the same. Ray AB is exactly the same as ray AC because they both go in the same direction. Okay, let's talk about betweenness. How do I know if a point is between 2 points? And I know I apologize. It's like you just look at it. Hello. It's quite obvious. I get that. But how do we state that mathematically and precisely? And here is an example. I just drew a line. Like, notice these points S, P, and R. How do I know that P is between S and R? So P is between S and R if ray PR, the intersection of ray PR and PS is point P. Now I know it has to be then between those 2 points. Now because P is between S and R, then that means that PR and PS are opposite rays. So two rays are opposite rays if when you put them together you end up with one line. It would be like you having two ray guns and you would do one ray in one direction, the other ray in the other direction, and it makes a straight line. then they are opposite rays. Okay, another subset of a line besides rays and opposite rays are segments. So a segment is all the points on a line just between 2 points. You have the two ends. So for instance, if I have the segment SP, notice my line above the S and above the P do not have arrows on either direction because they are both endpoints. S and P are included in that segment and all the points in between. Okay, let's apply this, see how well we understand it. I'm going to give you some questions. These are true, false. I want to know, is this statement true? So I drew a line on the board and included 5 points on it, A, B, C, D, and E. And I made this statement: ray, the intersection of ray CD with the half line CA is equal to point, the set of point C. Is that true or false? And it looks like it's true. I mean, CD goes this way and CA goes that way. The only problem is in the half line CA, C is not included. So therefore they don't have it in common. So this is false. I hope you saw that. Okay, another statement, a little different. I have ray CD again, but now it's the union of ray CD with the half line of CA. And we're saying that that is equal to line AE. Is that true? If I start at C and do a ray in this direction, and start at C, don't include it, but do the half line on this side, the A side of C, combining those two, would it give me the entire line? And yes, it would. This is true. Because even though C is not included in this half line, it is included in that ray. So it doesn't leave point C out. So this one is true. Okay, let's try one more with this line. I have ray BC. So I'm starting here at B and I'm going to eternity in that direction. That's this. The intersection of that, so what it has in common with ray ED. Okay, ray ED says I'm starting at E and I'm going in the direction of D. So BC is sort of like that, and ED is sort of like that. And is that intersection segment EB? What do you think? It is, yes. So if we went ahead and drew these out, you could see that this is the part they have in common, which is segment EB. So that one is also true. Okay, we took lines, we divided them up. Let's do the same thing with a plane. Here's a plane that I drew on the board, and I drew a line M kind of through the middle. That divides this plane, because remember, even though I didn't draw it all the way to the end, I have the two arrows to show they do go for all eternity. So it divides this plane into two half planes. I wrote an H1 on this side and H2 on the other. Each one of those is a half plane. The edge of that half plane is the line. So it's not on the plane, just like the point was not on the ray, remember? On the half line. Same thing with this plane. The line is not there, it's just the edge of the plane. So I have two halves, H1 and H2, each have the same edge, line M. Notice points A and B are on the same half plane, so therefore the segment joining them would also be in the same half plane. B and C are on opposite half planes, so if I drew a segment connecting those, they would intersect line M because they are in the two different half planes. So just like every point on a line divided a line into three disjoint sets, the two half lines and the point, the same exact principle applies with a plane. Every line in a plane creates three disjoint sets, the two half planes and the can put that in your notebook as the plane separation postulate. Okay, I drew a plane on the board. This is plane P, and we have line in on plane P, and we have points A and B and C, and the two half planes are K1 and K2. So let's analyze this. I want to know what's the intersection between line in and K2. What would your answer be? What's the intersection between this line and this half plane here? Think about it. Hopefully your answer was the empty set. Because remember, the line is the edge. It's not part of the half plane, so they don't have anything in common. Okay, another problem. I have segment AC. Notice this is a segment because there's no arrows on it. Segment AC and K1, this half plane. What's the union between that segment and K1? So think about that. What if I put them together, what would I have? Hopefully you would say that you would have the half plane K1 because that segment is within that plane. So just all of that half plane would cover it. Okay, an angle. An angle is also another way to divide up a plane. So this is similar to the 3 points I had earlier, but now I did them a little differently. And this is angle ABC, and an angle is the union of two rays with a common endpoint. So this is the union of ray BA and ray BC, and that becomes angle ABC. The sides of the angle are the two rays. So ray BA and ray BC are the sides of my angle. Side, aside. The vertex of the angle is that common endpoint. So B is the vertex, an important word. We will use it a lot. B is the vertex of your angle. Notice when we name an angle, this symbol here stands for an angle, and the vertex is always the middle letter. It's kind of interesting to look at this angle and think about it as dividing this plane into half planes. So if you looked at it as this line creates that half plane, and this ray, I said line, I should have said ray, divides that half plane, the intersection of those two half planes ends up being the interior of your angle. So the interior means the inside, in between the two sides of your angle. That's the interior of the angle. Of course, everything else then would be the exterior of your angle. Naming angles correctly is very important. Hopefully this is a review for you guys, but I'm going to review it because it's really important. So if I look at my diagram, I have angle YWZ. I want you to find angle YWZ, and I want to come up with some other names for the exact same angle. So angle YWZ would be this angle here. So one way to name that angle would be angle 2. We can say that's angle 2. We can also name it starting on the opposite side vertex to the other side. So instead of going YWZ, I could go ZWY. Angle ZWY is also the exact same angle. Take the time to write 2 other ways to name angle 1. If you need to pause the video and do it and then check your answer, do it just to make sure that you're really good in understanding this. Okay, hopefully you said one of them is angle XWY, and the other is to go the opposite direction, angle YWX. That should be a capital Y, sorry about that. Those are the 2 other ways to name angle 1. Okay, what's another way to name angle ZWX? So ZWX is the large one from here to here. One way to name it would be to go angle XWZ. Could we call it angle W? I hope you say no, because that is way too vague. It's not precise enough. Angle W could be angle 1, angle 2. There are 3 angles that have a vertex of W. So please do not try to call this angle W. You can call an angle by its vertex if there is only one angle at that point. Okay, again, this section also has a lot of vocabulary on page 24 in your textbook, so get that in your notebooks. Make sure you know what those terms are, and I will see you again in the next section.